Salam sejahtera and a very good day to everyone. My name is Stephanie and I represent Group N for this statistic assignment. Our group leader is Siti Azela and other group members are Siti Nur Umaira, Suresh and Wan Muhammad Nazrin. We already distributed the tasks equally among us. For hypothesis tests is done by Siti Azela and Nazrin, while simple linear regression is done by Suresh. For introduction and compilation of every report and videos is done by me and Umaira.
Assalamualaikum. I am Umaira. I would like to introduce a bit about this project. The product that we have to analyze the data is Lajak Kuruih tablets. There are 15 different types of tablets, but our group task is analyzing the data of Lajak Kuruih and tablets. For my part, I have to summarize the data into numerical, tabular, and graphical form. From the data given, 200 samples observations taken at random from 3 production shifts run daily, namely morning, evening, and night in December 2020. From the data given, we can determine the weight, percentage of relative density, and tensile strength of the tablets. Firstly, we analyze the weight of tablets produced. The range of the weight is from 310 to 390 mg. From the graph, the most frequent weight produced in December 2020 is between 350 to 370 mg. Next is the percentage of relative density. From the pie chart, we know that the percentage of relative density of the tablet is 83% and above. With the most frequent, it produced 87 to 89%. The other characteristics that we observe is tensile strength. The most frequent that the tensile strength of the tablets produce is 6.9 to 7.1 megapascal. Lastly, we know that the most shift that produced the tablets in December 2020 is night shift, with 35% production of Lajak Kuruih and tablet.
Assalamualaikum and hello everyone. My name is Siti Azila binti Mazlan. So I will discuss my part B. So this is the question. So I will first collect my data by creating a frequency table with suitable range of values and category. I highlight the value. Mean is 350, standard deviation is 14. This is my frequency table. So this is my normal distribution. The hypothesis for H0 is the weight of standard tablet follow the normal distribution with mean 350 and standard deviation of 14. For H1, the weight of standard tablet does not follow the normal distribution with mean 350 and standard deviation of 14. So this is my test statistic. This is the value for probability and EI. The value for EI number 1, which is 3.22, it is lower than 5. So we must merge it with EI number 2. This is my table that already merged. And this is for goodness of fit test. This is number 1, 2, 3, 4, 5, and 6. This is the formula x square test equal OI minus EI square divided by EI. The value for x square 0.05 with 5, I got from the table, statistic table, I got 11.0705. So reject H0 if x square test more than x square alpha. So the conclusion is x square test is equal to 1.3358, which is lesser than 11.0705. So we conclude that the weight of standard tablet follows the normal distribution with mean 350 and standard deviation 14 at alpha equal to 0.05. That's all. Thank you.
Okay, Bismillahirrahmanirrahim. So I will continue to my part, which is part C. The question is there any significant difference between the tablet from the different shift? The method I'll be using is one-way ANOVA in Microsoft Excel. This is to decide if there was any difference occurring between the population means from which the sample came from. As you can see at the slide, there is the hypothesis test, which is H0 is equal to mu1, equal to mu2, and equal to mu3. And H1 is Mi is not equal to Mj for at least one I or j. I is not equal to j. As you can see at the slide, the summary from evening, morning, and night, and the ANOVA, which we got from the Microsoft Excel. So as the calculated, the F calculated is equal to 0.297390, which means the p-value will be 0.743087. Therefore, p-value is compared to a chosen level of significance alpha. The rule is if p-value is greater than alpha, then H0 will be not rejected. If p-value is lesser than alpha, then H0 is rejected. Since p-value is equal to 0.743087, which is greater than alpha, alpha is 0.05, thus the conclusion is we fail to reject H0 or we accept H0. That's all from me. Thank you.
For question D, linear regression, predict the tensile strength and the relative density of Lajak Kuruih pill N. There is a relationship between the tensile strength of the pill and the relative density regardless of the shift. From the table, tensile strength is a dependent variable and relative density is an independent variable. When the confidence in linear relationship is more than 90% between the tensile strength of pill and the relative density, it means it is valid. The main equation is y equals to mx plus c, where y equals to tensile strength, m equals to gradient, x equals to relative density, and c equals to intercept. So these are the Excel analysis data we can get from the Excel analysis. So by plotting the graph, which is tensile strength against relative density, we can get the main equation, which is y equals to 0.0828x minus 0.1665. From the main equation where x equals to relative density, when substitute the relative density from the main equation, we can get the tensile strength. For the first one 68%, we can get 5.4639. For the second one 74.3%, we get 5.9856, and for the last one 80.1%, we can get the 6.4658 tensile strength. Here is an example calculation. From the predicted accuracy, the tensile strength is 88%, where we can get 7.2 megapascal. From the linear regression prediction, 88%, we can get 7.1199%. From the calculation, we can get 98.89%, which means more than 95%, and it is a valid and acceptable. So for the conclusion, the linear regression model is a valid model to predict the result of the tensile strength of the pill based on its relative density up to 95% accuracy. So that's all from our group. Thank you.